Hi, everyone. I received questions from the discussion leaders, from Tuesday's discussion leaders. I'm going to post this video with the responses. So the big question I think they had was to review the solution for question 1A. And at the beginning of lecture 3, I actually thought that I did review the solution for question 1A, but I just realized that the solution I walk through is the example in the first half of that, that packet. So this is actually probably better because now you get to see it twice. So you'll see, you'll hear me talk through the example that's in the incidence and prevalence worksheet document. And then right now I'll walk through the actual solution for question 1A. Okay, so let's do this again. So this is what I have here is a table of of the numbers they've given you. So they give you year, new cases, total cases. Or wait, let me make sure. No, they give you year, new cases, and the total number, right? Let me look at pull up the document. Year, newly diagnosed, and the number at risk. So the fourth column, I guess. All right, now what is the incidence rate? So incidence rate, remember again, is going to be your number of new cases over the number at risk at the beginning of the period. So this is always from the prior years. So I've actually set it up with year 0 in the table, which you see for question 1A, they actually don't do, but I think it makes it a little bit easier if I do it this way. So for the first year, at the beginning of actually, I guess it's week. For the first, I've written year, but it's actually week. For the first week, no one has developed any spring fever. And this would be, you could think of this as your first week back in school. So let's say school starts at the first week of September. So this is the first week of September. There's 1,000, the total number here, 1,025 students in your school. The other thing we assume for this is that no one new is moving into the school or moving out of the school. This 1,025, you always have 1,025 students in your school. And at the very beginning of that first week in September, no one has spring fever. But at the beginning of at the start, so 0.0, but at the beginning of the first week, so this is 105 people develop spring fever. So our incidence rate is our number of new cases over the number at risk at the beginning of the period, so from the prior year. In this case, then you're going to divide 105 over 1,025 to get 0.102 for the incidence rate. And again, incidence rate is telling us how fast someone's becoming a case. And here I've just written it out so you can see what I was doing to get these numbers. So 105 over 1,025, the number at risk. 180 over 920. So you have to sort of create 2 additional columns. One being the total number, and that's always 1,025, and 2 being the total cases. And for this column, so column 3, you're just adding column 1. So 105 plus 180 gives you 285. 285 plus 390 gives you 675. 675 plus 325 gives you 1,000. For the number at risk, the way they're calculating this is we're saying, okay, beginning of the first week, I have 1,025 students, and 0 cases have spring fever. At the end of the first week, 105 cases have spring fever. So then we go 1,025 minus 105 gives us 920. 920 minus 285. So the total number that's developed at the end of week 2 gives you 740. So maybe one way to think about this, the number at risk, is how many people are at risk at the beginning of the period, to the beginning of the week. And this number here is how many develop, how many cases of spring fever do we get by the end of week 1? All right, so now what about point prevalence? I think the third question your discussion leader sent me today, or sent me yesterday, was why do they call in the first half of the measures in epidemiology worksheet, they call this a prevalence rate. And I actually wouldn't, there is such thing as a prevalence rate, but for the purposes of this class, I'm not interested in having you learn or understand the differences. And I wouldn't call what they're calculating a prevalence rate. This is actually point prevalence. And the reason why the terminology isn't maybe consistent is just because epidemiology is a pretty new science. And we haven't always agreed about what we're going to call things. It's becoming more routine, but there are still things that people, and this is the case in all scientific fields, but there are still terms and definitions that people sort of quibble over. So your worksheet says prevalence rate, and I would like you to think of this as point prevalence. It also says in the denominator, in the definition in your worksheet, that the denominator is the number of persons at risk of having the disease at that specified time. And I think that's wildly confusing. For point prevalence, your denominator is just the total population. So here you guys can just ignore what the worksheet says. So your numerator is going to be the total number of cases for point prevalence, and your denominator is just the total population. Right, so if we look at year 1, 105 over 1,025 cases gives you a point prevalence of 0.102. So the same actually as your incidence rate, but then you see it change. So 285 total cases over total population, 1,025, 0.278. So the denominator here is never changing. The numerator is. And the numerator is going to be the cumulative, or the total number of cases. It's not the number of new cases, but the total number of cases. All right, next thing. And here, I guess you can see, so in this slide, I think this is part 1B, where they ask you to express the numbers, the incidence rate and the prevalence rate per 100 population. Let me look at the worksheet to confirm. Yes, question 1B, from your data above, convert the incidence and prevalence. It's convert the incidence and prevalence rate. Again, I want you to think of this as convert the incidence and point prevalence to rates per 100 and fill in the table below with your answers. All right, so to express something per 100, you just times it by 100s. So year 1, if we're changing this incidence rate, the 0.102 into a per 100 rate, we just times 0.102 by 10. So 0.102, I mean by 100. 0.102 by 1 times 100 gives you 10.2. Year 2, 0.196 times 100 gives you 19.6. Year 3, 0.527 times 100, 52.7. All right, that's the end of it. If there are more questions, please feel free to send them to me, and I'll try post video responses for you.